Alright, logarithmic functions 2.2. So the first says, find the answer to each logarithmic equation and explain how each equation supports a statement. The answer to a logarithmic equation is always the exponent. Well, we could type that into a calculator if we wanted to, or we could change it to its inverse, the exponent, which if we call that y would be 5 to the y equals 625. Well, we're trying to get what y is. Y ends up being the exponent. That should kind of key you into that. So 5 squared is 25, times by 5 again is 125, times by 5 again, so 2, 3, 4. So the answer would be to the fourth, or 4. Okay, for number 2, we'd go 3 to the y equals 243. Well, 3 squared is 9, to the third is 27, to the fourth is 81. 81 times 3, so to the fifth, that would give us 243. So that would be 5. Once again, the exponent of the inverse tells us the answer of the logs. Okay, now we're getting a little more difficult. Okay, number 4 is pretty easy, right? 9 to what power would be 81? Well, it'd be squared, so the log base 9 of 81 is 2. Okay, log base 5.2. So 5 to what power would be 0.2. Well, what's 0.2? 0.2 is 2 over 10, or reduced is 1/5. Remember, 5 to be 5 would be to the first. To make it a fraction would be negative, so it would be a -1. Okay, log of 1 million. So remember, if they don't tell you the number, it's like it's got a base 10. So log base 10 of 1 million would be 10 to what power equals 1 million. Well, 10 to the first is 10. 10 squared is 100. 10 cubed is 1,000. So what do we got to get to? Like 10 to the sixth? Because that's how many zeros there are? Probably. So the log base 10 of 1 million is 6. Log base x of x to the 7th, well, x to what powered would equal x to the 7th? Has to be 7. So hopefully you see that that's where the connection is, right? The inverse is the input to the output. Alright, now transformations on logarithmic functions. Okay, so number 7. What is the value of x when f of x equals 0? So remember, the x stands for the input, the 0 stands for the output. So if I go to 0 for my y value over to my graph, the input would be 1. What about when we're 1? 1 would be up here, so I go over there and it looks like it's about at 2. So x would be 2. Value of f of x when x equals 2. So if I go to 2 and then go up, it looks like it's not quite to 3. I'd probably guess almost like 2.5. So f of 2 would equal about 2.5, we'll say. Okay, what will the value of x be when f of x equals 4? So if we go up to 4, go clear over there. See, we're running out of space here now, aren't we? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, maybe 12. Okay, maybe 12. Now E wants to know what the equation of this graph would be. Well, let's make a table. I think that'll help us out. So at 1 we have 0. At 2 we have 1. Or no, 1 we have 2, right? Wait a minute. Yeah, we have 1, 0. Hold on. Because at 1, see why they say you may want a straight edge to help you out with that. So when x is 1, y is 0. That's what number 1 told us. When x is 2, y is 1. It says what is the value of fx when x is 2? Oh, did we go? I went too far, duh. What was I thinking there? That should be 1. And then we wanted to know what we got when we got to 4. Okay? So we need to figure out what the equation of this graph is based off of this information. Well, we know it's going to be a log. Okay? So let's flip that around. If I have 0 to get to 1, so what power to the 0 would equal 1? That could be anything. That doesn't help me. When I have 1, I get to 2. So that would be 2 to what power? The power of 1 gets me to 2. Would have to be 2. So I have log base 2. Okay. Of x. In order for these first two to work, right? Because log base 2 of 1 would have to equal 0. Because 2 to the 0 would equal 1. Log base 2 of 2 equals 1. Okay, 2 to the 1 would equal 2. So what would then 4 be? Well, we can, if we're using this log base 2. So log base 2 of 4 would equal what? So 2 to what power would equal 4? It would have to be 2. Huh. See, that doesn't seem to work out, does it? Oh, it's because log base 2 of what would equal 4? I was doing it backwards, wasn't I? So it'd be 2 to the 4th equals what? Well, 2 squared is 4, times 2 is 8, times 2 is 16. So that would have been x equals 16. 16. So we'd get that for our equation. Okay? Kind of a lot of work for that one, isn't there? Alright, let's try number 8 now. So number 8, what is the value of x when f of x equals 0? So our x-intercept is 1. Okay. So that would be 1, 0. What is the value of x when f of x equals 1? So if we go over here, looks like that's at 3 to me. So we'd have 3 and 1. What is the value of f of x when x equals 9? So if I go up here, that looks like it's 3 or 2. So at 9, it would be 2. What will the value of x be when to get to 4? What would x be here? So once again, to help us get the equation, let's flip this around and think of, this is our log. This is going to be our exponential, our inverse. So it'd be 0, 1, 2, and then eventually 4. So we'd have 1, 3, and 9. Well, the first one doesn't really help us, right? Because anything to the 0 power equals 1. Second one does help us, because 3 to the first is the only way we can equal 3. With this one, 3 squared would equal 9. So we have a base of 3. So for my equation, I know I have log base 3 of x. Okay, would equal y. Now, how can we use that to figure out the 4 here? Well, what's 3 to the 4th? That would be 81. So 81 would take us clear to 81 to get to 4. And there's our answer on that one. Alright, taking a look at the other page. Now it says use the values and the graph of values for the graph. Use the graph and the table of values for the graph to write the equation of the graph. Explain which numbers helped you out the most. Well, I'm going to tell you right now, these numbers that don't have decimals, probably going to be the easiest ones. Okay, because let's flip it around. So let's make our x and our y the inverse. So -2, -1, and 0. And we get 9 here, 3 here, and 1 here. So let's think, what to the -2 would equal 1? What to the -1 would equal 3? And what to the 0 would equal 9? So, if we just had this one, I would say our exponential equation would be 9 to the x. The problem is 9 to the -1 would give me 1/9. So how do I take 1/9 and get it to +3? Okay. We could times it by, not by 3, we'd have to times by 27. 27 divided by 9 would give us 3. Okay, but would that work for the 2? No, because I'd have 1/9 squared times 27. That would be 1/81 times 27. Wouldn't get me where I need to go. Okay. Also, something I should notice here. These ones here had a y-intercept or an x-intercept of 1. This one doesn't. It looks like it's shifted down 2. That tells me something. Because of that, also, these ones have an asymptote at the x-axis. This one could have an asymptote at the x-axis because we don't know what x, when we get to 0, what it equals. Okay? So, let's say that tells us that we're probably going to have to move this vertically, so we're going to subtract something. So we'd have something to the -2 minus 2 would equal 1. Something to the -1 minus 2 would equal 3. Something to the -1, or to the 0, minus 2 would equal 9. If we added 2, I know that would be 1, so I'd have to times by 11. So 11, see, this isn't making much sense to me with that. Seems like it shouldn't be this hard, should it? Alright, took me some thinking to get this figured out. So, we could change it here. These ones are going to be our most helpful. Okay? Now, what we need to think through is that if this were we're dealing with the exponential, which would look something like this. Okay? Where this would be that same point right here, and the y would be 0, 9 right there. Okay? So that's a horizontal shift. So when we think of this minus 2, it actually, when we go something to the -2, we're actually going to add 2 to that. So -2 plus 2 would give us something to the 0, which would equal 1. Okay? But that doesn't really help us narrow it down. So if we look at this one, and we go some power to the -1 plus 2 equals 3. Well, -1 plus 2 would be 1. What to the first power would equal 3? Has to be 3. Okay, and we can check that. 3 to the 0 plus 2, that would be 3 squared, which would equal 9. So that tells us that exponentially speaking, our exponential equation would be y equals 3 to the x plus 2. Now, if we're switching this around to logarithmic, we make that y, we make that x, then we go log base 3 of x equals y plus 2, then we subtract the 2, so we get log base 3 of x minus 2, which when we type that in to Desmos, that would give us that equation. You can double check it. Okay, so we kind of got to think there, didn't we? Let's take a look at 10. So now negative 2 says error. That tells us at negative 2 we have a vertical asymptote. Okay, then negative 1 is 0. Okay, so once again we think of it like this. So 0, negative 1, then 1, 1 would stay the same, then 7, 2, or 2, 7, right? So now we've got to think about that. So now looking at this, normally the parent graph, okay, has that right there. It's shifted to the left 2. So from 1 down to negative 2. So just like this one shifted this way, now this one would be that vertical shift if we were able to take this and rotate it up to be our exponential. So it's going to be something to the power, like negative 1, and then the 2 would be a minus 2 outside here. Okay, different than it was for 9, because 9, it's got a vertical, so its inverse would have a horizontal. This one has a horizontal, so its inverse would have a vertical. Okay, so we can say what to the 0 power minus 2 would equal negative 1. Well, anything to the 0 would be 1. 1 minus 2 would give us negative 1. Okay, so it would work just having that minus 2. But let's try it with 1. So what to the first power minus 2 would equal 1? Well, again, anything to the first would be that same thing. 2 minus 2 would be 0. 3 minus 2 would give us 1. So let's try this one. 3 squared minus 2, would that equal 7? 3 squared is 9. 9 minus 2 equals 7. So our exponential is y equals 3 to the x minus 2. So now see that 2 is in a different position. So now when we solve it first, we add 2 after changing the x and the y. So we get x plus 2 equals 3 to the y. Then we do the logs. So log base 3 of x plus 2, and we put that in parentheses, equals y. There's our equation. And those guys helped us out immensely. Okay? I know those ones were very difficult. Good thing you had me here. Okay, now these just dealing with power to a power rules with exponents. So remember, you take a power to a power, you multiply. So 2 to the third to the fourth power is really 2 to the 12th. Why? Because that fourth makes it 2 to the third times 2 to the third times 2 to the third times 2 to the third. When you have the same base and the powers, you add the powers, 3, 6, 9, 12. Okay, that's why it works. So x to the 3 to the second would be x to the 6th, 3 times 2. A to the third to the negative 2 would be a to the negative 6, but it wants only positive. That negative makes it 1 over a to the 6th. For 14, since those are multiplied, the 4 kind of distributes. So 2 to the 12th times w to the 4th. Okay. Now, should we simplify that? Yeah. 2 to the 12th, we probably really should say what that is, which I don't know offhand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. So that'd be 4096. So I guess we really should call that one 4096. We'd call this one 4096 w to the 4th. Okay? So b to the negative 7 to the cubed, well, that would be b to the negative 21, which would be 1 over b to the 21. D to the negative 3 to the negative 2, well, negative times a negative is a positive, so that would be d to the 6th. Okay? X to the 5th times 2 would be x to the 10th, times x squared would be x to the 12th. Because when you got the different bases and you're multiplying, you just add exponents. Okay, m2 to the m3 would be m to the 6th times m to the negative 3. Negative 3 plus 6 would be m to the positive 3. And the last row to finish this up, x to the 5th to the negative 4th would be x to the negative 20th times x to the 25th. Add those together, or make it x to the 25th over x to the 20th, and you'd subtract. Either way, you end up with x to the 5th. 5 squared is 25. A cubed squared would be a to the 6th. 6 to the negative 3 would be 1 over 6 to the cubed, which is 216. 6 squared is 36 times 6 would be 6. 3. 6 times 3 is 18, 19, 20, 21, yeah. So it would be 1 over 216, but that's still squared. So 1 squared is 1. 216 times 216, I'm going to have to figure that one out. 6, 3, 9, 12, 0, 6, 1, 2. Calculator would have been very nice right here. 2 zeros, 12, 2, 3, 4. So it'd be 6, 5, carry, 5, 6, 6, 4. So it would be 1 over 46,656. Hopefully I did it right. And that last one, 2 squared would be 4. A cubed squared would be a to the 6th. B squared squared would be b to the 4th. And there's our last answer.